This is your equation for the parabola that we are going to start to get used to. This is the parabola that you're used to. And you've worked with the vertex. The brand new thing for us today is focus and directrix. You've never seen that before. The y equals x squared that I mentioned, that you've graphed before in Algebra 1, that was a very, very simple form of the parabola. A very, very specific form of it. This is the actual form of the parabola. So if you go on to Algebra 2, you may deal with this, or math analysis, basically any course beyond geometry deals with this a lot. The things that are really new for us are focus, directrix, this thing, this is axis of symmetry, which we won't really do on our tests, and this part P. Now the H and K look familiar, we'll go over that in a minute. But just to explain, first of all, what this focus point is. If you look at this drawing, there's your vertex, there's your directrix. The focus and directrix basically work together to make the parabola. The official definition of parabola that you never heard before is all the points that are equidistant from the focus and directrix. What does equidistant mean? Equal distance, the same distance from. So if you notice these lines are just there to show you that from the focus to the directrix, this point would use this distance from the directrix, this distance from the focus, that's the same length. So if I picked a point out here, this distance to the focus, this distance to the directrix is the same length. That's how all these points come to be. That's how it forms the parabola. Now for an application, because again, focus point, you've never heard that before, you've never seen it before. If you have a satellite dish, anybody have a satellite dish at home? For TV? No, only one? Oh, okay. For a satellite dish. This is direct TV.
It's a balloon.
Oh. On your satellite dish, or any satellite dish you've seen, have you seen this thing? There's a little thing in the middle like that.
Oh, yes. Yeah.
Okay. If you take, first of all, if you take a satellite dish and you kind of slice it in half, if you look at the half that's been sliced, it look maybe a little bit like this. The piece that you see when you slice it is actually a parabola. That curve is a parabola. And if you take like a bowl or any kind of dish like that, any kind of bowl-shaped dish, you cut it in half, you're going to see a parabola. Now to create those parabolas, they use this focus point. So this thing you see on the satellite dish is actually the focus point. You don't see the directrix, that's imaginary line, but you see the actual focus. So the images, the signals from the satellite out in space come down here, hit the focus, it goes into the satellite dish. That focus helps focus all those beams to create the images on your TV. So that's where it's actually used. It is physically used in the satellite dish. That is your focus point. Now our goal today is taking this equation, figuring out where the focus point is, where this directrix is, and being able to graph it. Now the graphs are not very detailed at all. If we look here in these notes, there's a few steps, there's 5 steps that they want us to go through. First one says make sure the equation is in standard form. So just make sure that it looks like this, usually with parentheses, sometimes without. Find the vertex, HK. That should sound familiar. H and K, remember we did that with the circle. Find the value of P. This is the new thing. This P value is distance from the vertex to the focal point. And this is also going to tell us whether the parabola goes up or down. Now from what you did in Algebra 1, when you looked at the parabolas going up and down, what typically made you think the parabola was going to go down? It was negative in front, right. So if it's down, it's negative. If it's going up, it's positive. And we'll see how all of this looks in a moment. says also the distance from the vertex to the directrix, and we'll see how to graph that directrix. Find the distance to the directrix, which is equal to p units. Now the equation of the directrix, we're not going to deal with that as much. All we're going to really concentrate on is the vertex, the focus point, and graphing the directrix. For number 1 below, there's the first example. This is already in standard form, so we don't have to change the equation at all. We just have to start listing all the parts. So for the vertex, this is now we look at the x. What number is going to go into the x coordinate for the vertex? -1, right. We take this +1, we change the sign, -1. What's the y coordinate? 4. +4, opposite of the -4 gives you that +4. So now we're actually going to go ahead and start graphing it. We're just going to graph the vertex points. So we go to -1, left 1, 1, 2, 3, 4, up 4. Now the p-value. We're going to take that number in front of the y. That's matching up with this 4p. We're going to rewrite it as 4 times something. And it's always going to be a multiple of 4. The really hard ones, which you wouldn't really deal with until algebra 2, are when it's an ugly number. But here it's always going to be something times 4. What's going to go in here? 6, because 4 times 6 gives you the 24. So our p-value is +6. So does this parabola point up or down? Up, because that 6 is positive. Now when you graph the focus is always inside the curve. It's always inside the parabola. So from this point now, we're going to go up how many units?
4.
6, that p-value. It's going to land right there at +10. Now what that means is that the parabola should open up this direction, and the directrix should be below it. Now that distance we went for the focus, we're doing the same distance for the directrix. So from here we're going down how many units? 6. 1, 2, 3, 4, 5, 6. Now it's not just a single point, it's a horizontal line. There's your directrix. Now for the actual parabola, I don't need much detail. We don't even need to plug anything in. All I'm concerned with is just that you make a quick sketch so I know you know that it's going up. And that's it. Honestly, that's all you need. On tests, individual tests, I don't think you even have to graph it. What's more important is just writing it in standard form and then stating vertex, p-value, etc.
So does it matter like how big or anything it is?
No, as long as, well, I wouldn't draw it like this, but I mean, I wouldn't, honestly, if it was on a test, I wouldn't take points off. As long as I saw it was opening upwards, that's fine. Any other questions on number 1? For number 2 then, we'll look at number 2 together, then I'll stand for a little bit. For number 2, is it in standard form first of all? Yes, you got the parentheses, you got that number in front of the y on the outside. What is the vertex? 2, -1, good. Changing both signs, opposite of -2, opposite of +1. What is our p-value?
4.
-2. So if we split it up, 4 times -2 gives us the -8. So that's -2. So now, based on that -2, is it going up or down? Down. Now graphing the vertex, right 2, down 1, there's 2, -1. Now from there, where do we go? 1, 2. There's our focus point. Which direction for the directrix? Up 2. Quick sketch, and then you're done. And keep in mind that this is a very easy version because we're not dealing with parabolas that open up to the left or to the right. In algebra 2, you get to deal with those. For here, we're just going with the ones that go up and down. As you start on the back, 3 and 4 are more graphing like we just did. If you think you know how to do example number 2, go ahead. If not, we'll bring it back together for that. We'll definitely check that together later. But I'm going to start stamping. You're starting 3 and 4 right now.